Greetings to all. I welcome you all to the chemistry online class. Students, the last class we have discussed about the concentration of ore and how to concentrate the ore. We studied 4 different methods. I hope that you all studied the portion which I have given in your worksheet. Today we are going to see about the next topic, that is the properties of metals. Elements have been divided into metals, non-metals and metalloids, isn't it? While learning periodic classification you studied, am I right? So the elements are divided into metals, non-metals and metalloids based on their physical and chemical properties. Today we are going to see what is the properties of metal or how the metals differ from non-metals. The first one, physical state. We know that 3 states of matter is there, isn't it? Solid, liquid and gas. So mostly the metals that exist as solid forms. Okay, my students? Mostly the metals exist in which state? Solid state at normal room temperature. At normal temperature, metals will be in the form of solids. Except mercury and gallium. Mercury is liquid and gallium it's solid, but at high temperature, at hot conditions, it starts to melt, okay, and form liquids. Okay, ma? So all the metals that exist in solid state except mercury and gallium, it becomes liquid form in hot conditions. So the mercury is liquid in nature, remaining all the metals that exist in nature in the solid forms. Okay, because in that the molecules are tightly packed. Okay, that is 2 atoms together. Okay, like a crystal or lattice, it is tightly bonded. So most of the metals they form what? Solid. The next one is luster. What is meaning of luster? Luster means shiny appearance, isn't it? We know that most of the metals give shiny appearance. They reflect light when it falls on it. When it falls on the surface of the metals, it starts to reflect light. And also we can polish the metals to make it very shiny. To make it very shiny, we can polish some metals. Can you say some examples for the metals which is highly luster? You know, isn't it? Gold, aluminium, etc. Isn't it? Silver, etc. show shiny appearance on polishing. The next one is hardness. So what is the first property? Physical state. What is physical state? They exist as a solid form. The majority of the elements exist in a solid forms. In that molecules are tightly packed. Second one, luster. Most of the metals they show what property? They possess high luster, shining appearance. Okay. Third one, hardness. Most of the metals are hard and strong. You know that metals are hard and strong, which is used for various purposes, isn't it? Metals are used for making utensils since they are very hard and strong. Then for the parts, okay, for the making batteries, parts of the car, to make the alloyed metals of used in the making aircrafts, the parts of the aircraft, pressure cooker, etc. So due to their hardness and strong, they are okay. So most of the metals that are exist in very hard and strong, but except sodium and potassium that can be cut with knife because they are very soft. Except sodium and potassium, okay, remaining all the metals are hard and strong. Even sodium and potassium can be cut with the knife, so they are very what? Soft in the sodium and potassium are very soft in nature. Remaining all are hard. The next property is melting point and boiling point. For every element, it has its own melting point and boiling point. Usually, the boiling point of water, 100 degrees Celsius, isn't it? But this metal possesses very high melting and boiling point. At a high melting point only, which one starts to melt? Our metal starts to melt, and it can be also vaporized at a high temperature. At a high temperature, we can convert the metal into its vapor state. Except what are the metals? Gallium, mercury and sodium, potassium. Because already gallium, I said, no, it is little, that if the temperature of the varies from the normal temperature itself, they start to melt. Okay, gallium. Mercury already in liquid temperature. Sodium and potassium, it's a very soft metal, so it also starts to melt at a low temperature. But remaining all the metals, they need high melting point and boiling point, and at a high melting point they start to vaporize. They start to what? Vaporize. Have you understood, students? So melting point and what? Boiling point. So for example, the boiling point of is 660 degrees Celsius. Okay. So the aluminum starts to melt at what temperature? 660 degrees Celsius. So the melting point of aluminum is 660 degree Celsius. Okay. And what the metal which have high melting point is tungsten. Okay. Which need high temperature to melt and to make it into vaporize. The high temperature of which metal need means it's a tungsten. Tungsten metal, it needs what? High temperature. Whereas which needs low melting point is gallium, mercury, sodium and potassium. Have you clear, students? Next we are going to see about what? Density. Next we are going to see about density. Usually metals have high density. Why? Means the thickness is more, isn't it? Because there the atoms and molecules are densely packed. The atoms are densely packed, so they have what? High density. Except sodium and potassium, since only they are very soft because it is not tightly packed. Okay. So, and also it has very less density for sodium and potassium. If you take a sodium and potassium metal and if you put it in the water, it floats on the water. Sodium and potassium will float on the water because it has density less than water. It has thickness less than the water. Okay, students? So density, metals usually possess what? High density because of the arrangement of atoms in it. But except which one? Sodium and potassium, because it has very less density, so that if you put it on the water, it float on the water. Have you clear? Students, iridium and osmium are the two metal which has the high density when comparing to all. When comparing to all the metals, iridium and osmium has the highest density, whereas lithium, sodium, potassium all has less density. Okay, like sodium and potassium, lithium also has what? Less density, but osmium and iridium are the highest density containing metals. Next we are going to see about ductility. Next term or next property regarding metal is what? Ductile, or you can say ductility. The meaning for ductile means it can be drawn into thin wires. Ductile means what? Which is the substance that can be drawn into thin wires is called as what? Ductile without breaking. You know that, isn't it? Copper, it is used to what? For electricity, isn't it? Copper wires are there. Copper is more ductile in nature. Gold is more ductile in nature. They can be drawn into thin wires for a long, isn't it? So ductile means the metals that can be drawn into thin wires without breaking is called as what? Ductility. So metal is the most ductile substance, isn't it? Metal, that is gold, silver, copper, aluminum all are have what? More ductility that can be drawn into wires. Okay. For example, 100 gram of copper. 100 gram of copper can be drawn into wires for 200 meter long. Okay, that much they are ductile. Have you understood? 100 gram of silver can be drawn into thin wires up to how many meter long? Means 250 meter long. Like that, gold also a very ductile element. It can be drawn into thinnest form. Okay, even 1 gram, we know, isn't it? You can stretch the 1 gram of gold into long, isn't it? So gold, copper, silver, aluminum all are more ductile in nature, isn't it? Copper wires are there, aluminum wires are there, silver, etc. can be drawn into wires. That is called as what? Ductility. That character of the elements only called as what? Ductility. The next property is malleability. What is malleability? Ductile and malleable. Ductile means metals that can be drawn into wires. Malleable means they can be make it into sheets. Okay, thin sheets. Thin wire means ductile. Thin sheets means malleable. Okay, so by using hammer, we can beaten the metals into thin sheets without breaking. That property is called as what? Ductile. Iron, isn't it? Aluminum, etc. These metals we can beat with the hammer and make it into very thin sheets without cracking. But except the metals zinc and mercury, you cannot see this property is in what? Zinc and mercury. Remaining all the elements, nearly 80 percentage what? All the metals are malleable. So students, ductile means what? They can be drawn into thin wires. They can be stretched into wires. Malleability means they can be drawn into thin sheets. Okay. For example, aluminum foil. You have seen aluminum foil for wrapping what? Sweets, isn't it? For cooking, etc. and all. You will see that aluminum foil. Have you seen the aluminum foil? For wrapping the sweet, it is used. For some making bottle caps, it is used. Okay. For cooking, they used this aluminum foil. They are made up of aluminum and it is a very thin sheets. Okay. So gold also a highly malleable one. Okay, but zinc and mercury does not show this property, that is malleability. Have we clear? So what are the properties so far we studied? They are solid, they show lustrous. Next one, they are very hard and strong. Usually they possess high melting and boiling point. Density is high. Iridium and osmium is the high density containing element. Ductile, metals are drawn into wires. Metals can be made it into different shapes by hammering them. Okay, the next one is conduction of heat and electricity. From the lower class itself you might study it, isn't it? Difference between non-metals and metals, isn't it? So how the metals are the good conductors of what? Heat. So silver and copper are excellent in this property, isn't it? We know that silver and copper are the good conductors of heat and electricity, whereas tungsten, what? Lead, bismuth are the poor conductors of heat and electricity. You know that metals are the good conductors, isn't it? For cooking we are using, for what? Exchange of electricity we are using what? Metals. So metals are the good conductors of heat as well as electricity, but which is the poorest one, which have low conductivity of heat and electricity are tungsten, lead, bismuth, mercury, etc. show very low property. That is, it shows very what? Poor heating and poor properties in conducting heat and electricity. The last one is solubility. What is soluble? We know that metals do not solve in what? Do not dissolve in liquid solvents. It never dissolves in what? Liquid solvents. So many solvents are there for you. See, what is called as universal solvent? Water is called as what? Universal solvent. Metals do not dissolve in water. All those solvents such as water. Other than water, the liquid solvents we have benzene, ether. We have two types of solvents, organic and inorganic solvents. So in liquid solvents, malleability is not possible for metals. Metals do not dissolve in liquid solvents. Okay, thank you. So the next topic, so we completed what? The properties of metals. Okay students, 9 properties are there. You learn all the 9 properties. They will ask, write any 5 properties of metal. So don't skip this portion. Already one question is asked in the previous year. So learn here at least any 5 points regarding the properties of metals. Next we are going to see about the chemical properties of the metals. Okay, First one, valence electron. What is valence electrons? The number of electrons that are present in the valence shell is called as what? Valence electrons. Okay. The last class we studied while studying periodic classification. For each atom, the outermost shell is called as valence shell, and the electrons present in that shell is called as valence electrons. Usually, atoms, they contain in the outer shell either 1, 2 or 3. Okay, maximum 3. Okay, more than 3 means it is for non-metals. For metals, the outermost shell contains either 1 or 2 or 3. For sodium, you take the outermost shell contain 1. Magnesium, if you take and see the outer shell, it contains 2. Aluminium, outermost structure, it contains 3. So, the metals usually possess the valence electrons from 1, 2, 3 in their outermost shell. 4 to 7 is what? The non-metals. 4 to 7 is for what? The non-metals. Carbon 5, isn't it? So, outermost shell contains what? Either 1 electron or 2 electrons or 3 free electrons which take part in chemical reaction. The next one is formation of ions. Okay, mostly the metals are electropositive and the non-metals are electronegative, isn't it, students? Because metals, they lose their outermost electron. Either it can lose 1 electron or 2 or 3, okay, to form the ionic bond. So, they lost the electrons during chemical reaction and they become electropositive, isn't it? Here are some examples. See, sodium at the neutral state, it does not have any charge. It is neutral without charge. But when it is loose electron, it gains 1 positive charge and it's become what? Electropositive. Magnesium lost 2 electrons and it is become it receives 2 positive charge. If the metals lose 3 electrons, they get what? 3 positive charge. So, most of the metals are electropositive in nature and non-metals are electronegative in nature, or else you can say metals are the donors of electrons. Why they are electropositive? Another one reason is metals usually possess low ionization energy. Usually it possesses what? Low ionization energy. So, during chemical reaction, they never gain electrons. They lost their electrons during chemical reaction. Next one is discharge of ions. Okay. During electrolysis. What is electrolysis? Did you hear this word before? Electrolysis means electrical energy is to produce chemical change. Among the reaction, we will use electrical change. Electrical energy is used to produce the chemical change, that is called as electrolysis. So, what is electrolysis? Electrical energy is used to produce the chemical change. Electrolysis means it forms ions during chemical reaction. Chemical reaction is brought about by electrolysis to form the respective ions. What are the 2 types of ions? We have cations and anions. And what are the 2 types of electrodes? We know cathode and anode, isn't it? During electrolysis process, what happened means all the ions, that is metallic ions, that moves towards the cathode. Metals are discharged at cathode during the electrolysis of their compounds. Okay, so metals always gather near what? Cathode, and the non-metals or other parts move towards the anode. Okay, for example, electrolysis of aluminium, ions, aluminium ions moves towards the cathode, where the mud, the impurities or other particles that moves towards the anode. After electrolysis, we will separate the aluminium that is deposited at the cathode and we will purify. That process is called as what? Electrolysis. Okay, refining process. Electrolysis also we can call it as one refining process, isn't it? So, what is electrolysis? Electrolysis means a chemical change is brought about with the help of electricity, and during electrolysis there will be a formation of respective ions. The compounds split into their respective ions. For example, water means H plus and OH minus. the positive that moves towards the cathode. Isn't it like that? Here also the metals are discharged near to the cathode, whereas the other things they move towards the anode. Okay, the best example for electrolysis you will learn while we will study the extraction of aluminium. Okay, in that aluminium hydroxide, isn't it? Al2O3. Do you remember? Al2O3, aluminium. Okay, alumina or the ore of aluminium. While electrolysis, aluminium moves towards the cathode, where the oxygen moves towards the anode. So usually metals are discharged near to the electrode cathode. Near electrode cathode. What is the charge of cathode? Cations are positive, cathodes are negative. Like that, the opposite one also will come, isn't it? Anions are negative, anode are positive. The metals, while discharging or electrolysis, they gain what? They gain what charge? They gain what charge? They lose the electrons and they gain positive charge, and they move towards the cathode during electrolysis process. The next one is atomicity. The number of metals in the number of molecules in the metal, or number of atoms in the metal in their vapor state, is called atomicity. The number of atoms or molecule present in an element is called as what? Atomicity. Usually we know that metals exist in monoatomic form. It contains single atom. It contains what? A single atom. Okay, so monoatomic means it contains what? Single atom in vapor state. Okay, in solid state, all the atoms are tightly packed to each other. Here they will exist in vapor state. At high temperature, we can convert the metals into vapor form. In the vapor form, the molecules are loosely packed and it exists as a single monoatomic element. The next one is nature of oxides. Oxides of metals are usually basic. When you dissolve oxides of metal with water, they form a what? Basic solution. They form what solution? Basic solution. So usually the oxides of metals are basic in nature. Basic in nature. They show they are not acidic. They are basic in nature. For example, bauxite, cuprite, hematite are what solution? A basic solution. When you dissolve in water, they form respective their basic substances. Okay, so for example, aluminium hydroxide, bauxite, when you dissolve in bauxite, it forms aluminium hydroxide. Alumina, bauxite, okay, Al2O3, when you dissolve in water, it forms respective basic oxide, that is aluminium hydroxide, OH. Isn't it? Like that, hematite, they form iron hydroxide. They form respective hydroxides when dissolved in water. So all they are what solution? A basic solution. So nature of oxides. Most of the metals of oxides are exist in the form of basic. Oxides of metals are exist in basic. When you dissolve in water, they form hydroxides, respective hydroxides. Have you clear?